All right, guys, here we are, the last new lesson of the year in terms of notes and notes videos. So we made it, woohoo! All right, let's take a look here. We've been doing surface area and volume of prisms, pyramids, cones, and cylinders separately. We haven't discussed spheres at all. We are now going to do both the surface area of a sphere and the volume of a sphere on the same lesson. So try to keep that straight in your mind. Am I looking for surface area or am I looking for volume? All right, so looking at the sphere here, a sphere is simply a set of all points in space equidistant from a given center. So it's like a circle, but it's three-dimensional. I think you're familiar with what a sphere is. The radius, of course, goes from the center to the edge, and then the diameter goes from one end to one edge of the circle to the other through the center. Now, one thing that I chose not to work with in this lesson, but you may see written in your book, is this circle here, the one that goes right through the middle, something you might think of as the equator. Not necessarily the circle that's right here at the top, not that one, or even like a circle that might be down here at the bottom, but that one that's right in the middle, the one that's the biggest circle, is sometimes referred to as the Great Circle. That may seem like a silly thing to think about, but sometimes you're given information in terms of a great circle. They'll say, well, the Great Circle has an area of 49 pi. Okay, so then what would the radius be? Well, the radius would be, if pi squared equals 49 pi, then the radius would be 7. Okay, so sometimes you're given information like that. All right, without getting into too much great detail about how they came up with it, there is a formula for the surface area of a sphere, and the surface area of a sphere is actually 4 times pi times the radius squared. So the only dimension that you need to find the surface area of a sphere is the radius. In this particular example that they gave us, this is surface area. In this particular example that they gave us, the diameter is 10, and so that would mean the radius is 5. So 5 squared is 25. 25 times 4 is 100. So the answer here would be 100 pi meters squared. The reason that it's meters squared is we are doing surface area. So it's 100 pi meters squared. That's it. That's all there is to it. Now, one thing to think about is, and I didn't give you any examples like this, but perhaps you'll see this later. If you're given a hemisphere, that would be slightly different, because some people would say, oh, well, hemisphere is just half, right? Well, keep in mind that if you're doing the surface area of a hemisphere, that half would take care of the outside shell, but what it wouldn't include was that bottom circle or the great circle. So if you're ever asked to find the surface area of a hemisphere, you don't just divide this by 2. You would divide it by 2, but you would also have to add to it the area of the circle that's on the bottom there, which is pi r squared. Okay, so the surface area of half of that would be 2 pi r squared, plus the surface area of one circle would be pi r squared. So a hemisphere is actually 3 pi r squared, whereas a whole sphere is just 4 pi r squared. Okay, moving on to volume. Volume is kind of a weird-looking one. We know that the radius is going to be cubed, right, because we're dealing with cubic units, and we've just got kind of an odd little fraction out in front. So the volume of a sphere is going to be 4/3 times pi times r cubed. So we got a little bit of a strange fraction out in front. I could explain to you kind of why that is, but I think for remote learning, we could just accept that as the formula. It is kind of a neat formula to generate. I'm sure you can find some videos on YouTube if you're kind of interested where that came from. All right, so the question is, find the volume of the sphere in terms of pi. Well, volume is simply 4/3 times pi times the radius, which in this case is 6 to the third power. Because this fraction is something that guys sometimes have a hard time of dealing with, think of that as multiplying by 4 and dividing by 3. So you could do 6 to the third power in your calculator, multiply that by 4, and then divide that by 3. And if you were to do that, or if you were to do that in your calculator and just multiply by 4/3, you would get 288 times pi. So that would be 288 pi times our units, which is meters cubed. Now, if I were to ask you to find the volume of a hemisphere, well, then that would just be half of this. So you would just divide that by 2. You don't have to worry about the great circle because we're just counting the amount of area on the inside, not the area that's on the outside. So hope that helps, guys. Well, that's the lesson of the year. It's been fun. It's been good. We do have a quiz tomorrow, so make sure that you do the homework. You can take your notes. You contact me if you have questions. And even though there's not a quiz on Wednesday, there'll be a small assignment Wednesday, very small one. And I'm going to create a video for you guys, just some kind of last thoughts and kind of summing up the year, closing up the year for you. So please be sure to participate on Wednesday. There's some good stuff there. And I'll talk to you then. Have a great day.